Okay, so this is the Grizzly Parking app, kind of update one from the Code Wranglers team of Jared Hausman, Jacob Bradbury, me, and Paul Cardenas. So this is just kind of our overall briefing. The overview of the application is to provide predictive parking for students, show where parking is more likely to be found, and then to have this application work both on iOS and Android devices. So some of the requirements that the client gave to us were to fix the battery drain issue. They suggested to merge all of the functions and calculations to Firebase to help with this, so that all the CPU processing power was occurring on Google's side instead of on your actual device. And then adding additional parking lots to the geofence system, because the only lot that's currently working is the H lot. And then, of course, when you add new parking lots, you'd have to update the user interface to accommodate these lots. And then the last feature that they really want incorporated was to implement bug reporting. So our first sprint, which will take about 4 weeks, our main feature that we're working on getting is bug reporting. However, the app right now is pretty buggy, so we're having to spend a week to update all our dependencies and get it working. And then a week debugging some of the issues with connecting to Firebase. And then we'll start implementation once we get all the bugs that they wanted us to ironed out. And then we'll, of course, test that. So some of the user stories that we have as examples are, as a direct user, I want to be able to see where I'll be able to park on campus, because you want to be able to park quickly and get to class. Our second example is, as a direct user, I want to be able to report any bugs found in our software, because you don't want the application to be buggy, so you want developers to be able to fix problems that you encounter. So some of the code architecture that we have, this is the basic architecture where most of the development is done in the Ionic platform. And from the Ionic platform, we communicate with the Google Firebase database for things like authentication and storing data. And then in Ionic, we'll then break that down into both an Android and an iOS application. So this is kind of the file structure that was used with the application. And it's pretty much a standard Ionic type of application with a resource folder that breaks down into separate Android and iOS files, and then a source folder that has all the pages, apps, and components. So some of the technology that we're going to use is the Visual Studio IDE, GitHub for version control, Ionic mobile development platform, as I stated before, and the Google Firebase for the database interaction and authentication. So here is kind of an example of what a Google Firebase setup looks like. Here you can see that it is a non-relational database, so it works off of collections. So you can see the different collections that they have set up that we'll be implementing. So some of the future coding that we're working on is that there are lots of bug fixes that need to be ironed out. And then we're going to, like I mentioned previously, try and move all of the heavy-duty functions onto Google Firebase to decrease battery drain. And then we're going to add the other parking lots. And then one of the other things the client mentioned that they might like is to have an algorithm present to analyze student schedules and see when parking might be more readily available. So UI design. The current UI displays real-time information for possible parking spots. It's a pretty simple mobile application. So our projection is, obviously we'll enhance it to have other parking lots available, mainly the L gravel and A parking lots. And then so our future plan is that the UI will remain mostly unchanged. However, we'll implement those fixes. And that'll do it. Thank you.